Hey guys. So I had an email just a little while ago about some questions that you guys had on lab number 5, the last lab, and it's about the calculations, specifically questions 3 and questions 4. So I'll look at these right now, give you guys some hints for that. Questions 1 and 2, I'll let you guys worry about. It's simple mass by difference. You're just, subtracting and calculating masses. Question number 5, very straightforward once you know number 4, because you just put the answer to number 4 in the equation. So I'll let you guys worry about that, but I guess it has been a while, at least since Chemistry 1200, that you've talked about some of this stuff. So let's go. Question number 2, I'm going to make up an answer here. This is not the answer, but say I did this and I got 15 grams, or I guess 15 grams like that. Okay, so say that was my answer for question 2. Question 3 says, how many grams of total dissolved solids are there per liter of water? Well, the first thing to note is that in question 2, this 15 grams was in 250 milliliters of water. Okay, so to calculate question 3, it's actually pretty easy. If there was 15 grams in 250 milliliters, my question is, how many grams are there in 1,000 milliliters, or 1 liter? Now, you can do this using a formula. You can do this using dimensional analysis, but this is not something we did in environmental chemistry, so it's a few nights before your final exam. Basically, the easy answer to this is if we multiply this by 4, we get 1,000. And that's why I picked 250 milliliters, because if you multiply that by 4, you get 1,000. So all I have to do here for my answer to 3 is take my 15 grams and multiply it by 4, and I'll get 60 grams. Now, again, this is not the answer. Question number 2 is not 15, so make sure you use the correct number. Okay, on to question 4. What is the concentration of total dissolved solids in parts per million? Now, there's a few hints down here for question 4. The first hint is that parts per million is the same as milligrams per liter. And the second hint is that in 1 gram, there's 1,000 milliliters. So, I mean, you're pretty much there. This answer, the answer up in number 3, this is per 1 liter. Okay, so you already know the concentration in number 4. You know that the concentration in number 4 is 60 grams per liter. But I don't want that in grams. I want that in milligrams. So your job is to convert the 60 grams into milligrams. The conversion factor is right here. I'll leave that for you. The number will be quite big because the expected salinity for seawater is 35,000 parts per million, or 35 parts per thousand. So you will get a very large number, 35, 40, 50, 60,000 parts per million. In this case, I would get 60,000 milligrams per liter, or ppm. Okay, so my answer here would be 60,000 ppm. All right, I'll leave that for you. I'll leave the rest of it for you. Guys, all you have to do for question 5 is to put this answer in. This answer is your experimental value. So you can just put it in the equation that I gave you below. So I hope that helps. Good luck with the rest of your lab. And anybody listening to this, there were 2 students that already submitted their lab. I'm going to open it up and they can try it again if they think they made a mistake. Okay, good luck. Any more questions, send me an email. I'll be up all night, tomorrow morning, whatever. Okay, thanks. Bye.